Hi students, in this particular class we will try to understand the basic operational concepts of the execution of the program. How a computer will execute a program, what will be the sequence of events which will have to perform or which will have to perform by a computer to execute a program. So in this particular lecture we will try to understand what are the basic operational concepts of a instruction, how a instruction or a program will be executed by a processor. So first of all, we'll try to understand what is instruction. Instruction will be a command for a computer which will be used to perform an operation. So whenever we want to perform an operation, a command is required for a computer, and that particular command is called instruction. So whenever we will use such commands or instructions in a sequence in such a way that after the execution of that particular sequence, computer must be able to perform one task, and that particular sequence of instructions will be called as program. So a set of instructions used in a sequence manner will be used to perform a given task. So now, but where the program will have to be stored? The program will always be stored in the program memory of the computer. So let's suppose this is external memory. So this particular program will be stored in the program memory of this external memory. So before we will go ahead, we will try to understand what is the instruction. Let's suppose this is instruction or a command for any computer. It is written as load R1, LOC. So this particular instruction is having two parts. This load is called a mnemonic, and rest of the two words are called operand. So the first part, which is called mnemonic, is used to indicate the what type of operation we want to perform. So here load is written. The meaning of this load is we want to perform the operation or we want to load the data from the memory. So the second part is indicating the operand. Operand means the data or the address of the data or location of the data. So here in this particular instruction, the operands are indicating R1, in the form of R1, LOC, where R1 is a address of destination, and this particular LOC is the address of the location. So these two words are label, and the meaning of this instruction is we want to load the data from a source whose label, this LOC is location, short form of location, used as a label to indicate the address within the memory. So we will have to load the data from the memory, and that data will be stored or loaded to the internal register of the processor whose name is R1. So this is the meaning of this instruction. Similarly, if we will go with the second instruction, it is written over here, add R0, R1, R2. So meaning of this instruction is, as per the first part, which is called mnemonic, this particular instruction is used to perform an arithmetic operation called addition. So the data of the R1 will be added with the data of R2, and whatsoever will be the result after the addition, that will be stored within the R0 register. So if we will go and look at the third instruction, store R0, location 1. This particular instruction is used to store the data of an internal register R0 to an external memory whose location or whose address is indicated by this particular label called LOC1. So this store is the mnemonic which is indicating the type of operation, means we want to store the data, and second part R0, LOC1 is indicating the address of the operand, means the data will move from R0 to location 1. So this is how instruction can be written. So instructions, all the instructions will have to be stored in the program memory, and if we will look at the operands, and operands, the data, which is also called the data will be stored into the data memory. So this is all about what is the instruction, what is the program, what are the different parts of the instruction, including mnemonic and operand, and where the actually instruction will be stored, and where the location of the data will be there in the main memory. So now we will try to understand what are the different steps which are required to execute a program. So these are the steps which are required to execute a program: fetch, decode, read the data, execute, write back if required. So this particular diagram is showing a flow chart of the sequence of events which will be executed by the processor one by one. So what is the opcode? What is the fetching? What is the fetch? As we have already discussed that whatsoever the instructions we are using or commands we are using to write a program will be stored within the program memory. So to execute or to perform the given task, we will have to execute the instructions one by one in sequence. So whatsoever the operational code of the instruction will be stored within the memory, will be loaded from the memory to the processor, and that particular process is called fetching. So whenever the operational code of the instruction will be loaded from the external memory, wherever it will be stored in the memory will be loaded from the memory to the processor, it is called the fetching of the opcode or fetching of the instruction. Once the opcode will be fetched from the memory, it will move to the instruction register of the processor for the decoding purpose. So what is the decoding of the instruction? As the operation of the instruction will be having what type of operation we want to perform, what is the location of the data which is the required to execute that particular instruction, and what is the type of that data. So again we will go at this instruction load R1 comma LOC. So whatsoever the operational code of this particular instruction which will be stored from into the memory will be fetched to the processor, and again the opcode of this particular instruction will be in the form of binary, because the processor can understand the language of zeros and ones. It cannot understand the language of this load LOAD R1 comma LOC. So the actual operational code will be in the form of zeros and one, which will be stored within the memory. So once that particular opcode will be fetched, then processor will have to decode it of that particular instruction. What type of operation we want to perform from that particular instruction, what type of data is required, what are the different locations of those data. Okay, so all these things will be done by a unit which is called decoding unit. After the fetching, the instruction will move to the decoding unit. After the decoding, processor will come to know that what type of operation it will have to perform, what type of data is required, what are the different locations are there for the data. Then once it will get all these things after the decoding, so before the execution, it will have to read the data for the execution of the instruction. So what it will do, it will read the operands from the memory to the processor. If the data is required from the memory, then it will read from the memory. If the data is required from the internal registers or internal registers of the processor, then it will read the data from, or it will read the operands from those internal registers. So if we look at these three instructions which are given over here, in the case of first instruction, after the decoding, the processor will come to know that I will have to load the data from the external memory, and whatsoever the data I will loaded from the external memory will move to internal register R1. So naturally it will have to read the operand from the external memory. But in the case of second instruction, add R0 comma R1 comma R2. If we will look at this instruction, it will have to perform a operation called addition, but the location of the operands are within the microprocessor, because these R0, R1, R2 are the internal registers of the processor. So in this particular case, the processor will have to read the operand from the internal registers only. It will not access the data from the external. So after the decoding, the role of the processor is to read the operands. Whatsoever the location is, the processor will read the operands from that particular location. Then execute. So what is the execution? Execution is the process will perform the required operation, and this operation will be performed by the execution unit of the CPU. So once the operation will be performed as per the need of the instruction, then if after the execution of the operation, if there is a need to again store the result to the memory or in any register, that particular result will be stored to that particular register as well. Okay, so this is the basic operational concept of how an instruction will be executed by a processor. Now, before we will discuss the details of execution of an instruction stepwise, one by one, we will try to understand what will be the interfacing of a CPU with the external memory. Let's suppose this particular shaded area is the CPU, central processing unit, or a processor, and it will be interfaced with the memory through the three set of buses: address buses, data buses, and control buses. Broadly, if we look at this particular diagram, then we can see that this processor is having bus interface unit. The role of this bus interface unit is to interface or connect or establish the link between the processor and the external world. It may be either it may be a memory or a IO devices. So the MAR, which is a memory address register, will be used to store the address of the external memory or IO from where we want to fetch the either opcode or the operand. Program counter will be a special purpose register which will be used to store the address of the next instruction, whatsoever the instruction currently is executing by the processor, and whatsoever the address of the instruction which will have to be executed after the current instruction, the address of that particular instruction will be stored by the program counter. So this is the IR, it is called instruction register. Whatsoever the opcode will be fetched from the memory, that will be come to this particular portion. It is called instruction register, and this instruction register will be responsible to decode that particular opcode. Whatsoever the opcode processor is fetching from the external memory will be stored into the instruction register, and then this portion will be responsible to decode that particular instruction. What type of operation is required, what type of data is required, what are the locations of the data, if more than one data is required. This particular portion, this general purpose registers including the ALU, is called the execution unit. So these two blocks, broadly these two blocks are responsible to perform the type of operation, what type of operation we want to perform. Here there is a set of registers, namely R0, R1 up to Rn-1. These registers are called the general purpose registers, and it will be there within the execution unit. So these registers are used to store the data temporary during the execution of the program. So the size of these registers will be different. It will depend upon the what is the capacity of the that particular processor. So accordingly, size of these registers will be there. This is the ALU. It is used to perform all the arithmetic and logical unit, and this is the control unit, which is used to generate the different controlling signal at the different timing. Okay, so CPU is interfaced with the memory using bus interface unit of the CPU. So as we have already discussed that this is the bus interfacing unit of the CPU, and this particular portion will be responsible to interface the CPU to the external world. ALU of a processor has different general purpose registers. As we have already discussed that this particular portion is the part of the ALU as well, and are having the different general purpose registers. CU and BU has the special purpose registers. Control unit, CU is the control unit of the processor, and BIU is the bus interface unit. These two units of the processor are having some special purpose registers. As we have already discussed that this is PC, program counter. This is a special purpose register. We cannot use this program counter as a general purpose register to store the data during the execution of the program, because it is going to perform a special function, and the function of this program counter is to store the address of the next instruction which will be executed next. And again similarly, this IR also is a special purpose register. It is used to store the opcode only. So whenever the opcode will be fetched from the memory, it first of all it will come to this IR register. As we have already discussed that within the CPU a set of general purpose registers will be there, and a set of specialized register will be there, or special purpose register will be there. As we have already discussed that the role of the general purpose register is to store the data temporary during the execution of the program or after the execution of the program. Whereas what are the specialized register or special purpose register, the special purpose registers are used to perform the task whatsoever the task is assigned to those special function registers. We cannot use the special purpose registers as a general purpose registers. The function of IR and PC, we have already discussed that what are the role of this IR and PC. And next is the MAR. It is a memory address register. It is used to hold the address of the memory whatsoever the data or opcode we want to read or write to or from the memory. The address of that particular memory will be held by the MAR register. So whatsoever the address of the opcode will be generated by this program counter will go to the MAR, and then MAR will hold the address of the external opcode, and the address will be sent to the memory through the address lines. Control unit will send the control signal to the memory, and according to the type of control signal, either we want to read or write the data or opcode from the memory, the data will either move from the memory or to the memory on the data line. What is the MDR? MDR is the memory data register. Whatsoever the data will come from the memory or we want to write to the memory, the data will be held by this MDR, memory data register. So this is all about what is the interfacing of CPU and memory, and how the communication link will be established with the memory and processor. So in this particular slide, we will try to understand the sequence of execution of an instruction by taking one example. Let's suppose we want to execute one instruction, add R1, LOC. As we have already discussed that this instruction is having two parts. One is called mnemonic. ADD is the mnemonic which will gives us the type of operation, and R1, LOC indicating the address and type of the data. So what will be the sequence of event? As we have already discussed that what is the role of the PC, the program counter will be used to indicate the address of that instruction which will be executed next. Let's suppose we want to execute one instruction, then the address of that instruction will be there in the PC. So what program counter will do, the program counter will transfer the address of the next instruction which we want to execute to the MAR. MAR is the memory address register. So what MAR will do, MAR will transfer whatsoever the address it will receive from the program counter to the external memory through the address lines. So the external memory interface will be responsible to transfer the whatsoever the address is there in the MAR to the external memory through its address lines. Once the address will be sent through the control unit of the processor will send the read control signal to the memory through the control buses of the processor. Once the memory will receive the address along with the control signal, which will be a type of read, then the memory will be ready to transfer the data of whatsoever the address is there on the address lines. So the contents of the MAR address, whatsoever the address was sent by the MAR through the address lines, will be transferred. Data of that particular location which is stored in the form of opcode will be transferred to the MDR, which is the memory data register. So whatsoever the address will be there on the address lines, the data of that particular location will be sent to the MDR through the data lines. Okay, so once MDR will receive the contents from the external memory, then it will send the received opcode to the IR register for the purpose of decoding. So once the MDR will receive the opcode, it will send it to the instruction recorder or instruction register, which will be used to decode the instruction opcode. This is all about the fetching. This is all about the process of fetching of the instruction code from the memory. Now the next step is processor will have to decode this particular received instruction. So the decoding unit of this particular CPU will be responsible to decode it. What it will get from the decoding, after the decoding it will get what type of operation we want to perform, what type of operands are required, and what are the addresses or locations of the operands. With respect to this particular instruction, after the decoding, the processor will come to know that I will have to perform an arithmetic operation addition. 2 operands are required to perform the arithmetic operation addition, and at the same time it will get the locations of those operands. One operand will be from the external memory, another operand will be from the internal register. As we can see that R1 is the internal register, and so one operand will be there in R1 and another operand will be there in the memory. So after the decoding, processor will come to know that processor will have to read the 2 operands, one from the memory whose address is LOC and another from the internal register whose address is R1 or whose name is R1. So what it will do, by following the similar operation, PC will send the address of the required memory location, and data will come from the external memory to the MDR for the operand. Now in this case, after the receiving the data will not move to the IR because it is not a fetching, it is now operand read. So it will read the operand from the memory, and that operand will be stored within the MDR. The second operand will be fetched from the R1 to the ALU. So both the operands, MDR's operand will also move to the ALU, and the second operand from R1 will move to the ALU. Once these 2 operands will be available within the ALU, then ALU will start its operation called execution. Okay, so ALU will perform its arithmetic operation addition. So it will add the 2 received operand, one from R1, another from the memory whose location was LOC, and will give the result. Once the result will be ready, then as per the need of the instruction, execution unit will have to send it to the MDR. It will send to MDR, and once the result will go to the MDR, and then that result will move to the R1 as the need or location to store the result is also R1. So after the execution of the instruction, the result will move to the R1. Right control signal will be sent by the control unit to the R1, and data of the MDR will move to the copy to the R1. And at the same time, program counter will be incremented, and this increment will point the address of the next instruction. So whatsoever the current address was there, it will be incremented, and now the PC will be ready to point out the next instruction. So the next instruction again will follow the same sequence of event as per the need of the instruction. So this is all about what will be the sequence of events will be performed or executed by a processor to perform an instruction. Thank you.